Okay, na?
Okay, sir.
Okay, thank you. Uh, so in the last class, we discussed about the um, suspension bridge derivation. Suspension bridge with three-hinged Stefaning girder. Suspension bridge with three-hinged Stefaning girder. How to calculate the horizontal reaction at the support at different elevations and at the supports at same level. All these are derived in the equations last class, and how to calculate the bending moment at any section on the Stefaning girder. You are seen in the screen. M is equal to mb minus wx by 2 into l minus x. This is the equation gives the bending moment at any section. If it is different levels, supports at different levels, and also shear at a particular point on the Stefaning girder will be calculated by using these two equations. For one, if it is general equation is qb minus wl by 2 into 1 minus 2x by L. This is equation and gives the um, shear equation. So these from these equations, because the suspension bridge is used for moving loads, not stationary loads. In bridge, there is no stationary loads. Any vehicle is moving over the bridge. It is a you can calculate the moving vehicle for bending moment, shear force for the moving vehicle. So you must have knowledge of the little bit knowledge about the influence lines, which are you calculate and learn in the last previous semester in the fifth unit. I think it is a fifth unit. Influence lines and moving loads. So use a simple concept, that concept of the moving loads. Here you calculate the draw the ordinates from the derived equations. If it is a bending moment, you can derive the ordinate from mb minus wx by 2 into l minus x. In the shear force quantity is derived ordinate from this equation. So these equations are very important to draw the influence lines on the suspension bridge of the cables, uh, suspension bridges. So let us draw the influence lines for this case. What I am explained, what I am derive the equations. Uh, Same example. We will take the same example. For that, you can draw the influence lines. So let us DE is the already told in the derivation part. DE is the stiffening girder, and F is the third hinge will be kept at dot line, dot tick dot, and at any section on the girder is placed G. G is the at any particular section on the stiffening girder, which is located at A, and remaining part B. And third hinge will be kept at a distance L3, and it will be L4. Is a total L. So using, are you understand, students? The continuation part of the derivation of the suspension bridge of three hinge Stefaning girder. Students, yeah, are you able to hear my voice clearly?
Sir.
Yeah, okay. Now you're same. I already explained the previous derivation. I will take the Stefaning girder DE, which is third hinge will be kept at a distance L3. Already you know in the derivation, and G is the at any point on the section placed at a distance A. That's enough. Now for this positions, you can draw the influence lines. Okay. So how it is? Let us take for see. This is the A, figure A is the given problem, and B, you can draw the influence lines for intensity of the uniform distributed loading, and figure C will be the influence lines for the horizontal reaction, and figure D is the influence lines for bending moment at a particular section G. And similarly, bending shear force, figure E is the shear force at a particular point G. Okay. So these are all of you draw the figure. First draw the figure A, and then you can add one by one, how to draw the influence lines. Let us know in the derivation what is the equation of W. Put a heading influence lines for you leave separately. You draw the figure separately on one paper and put a heading. First influence lines for W. Are you understand? Let us take a paper and draw the diagrams. It's very important in the problems, or otherwise you cannot do the problem. Respond. Are you doing? Take one paper and
Yes.
scale and draw the figure A first. Draw the figure A. Already drawn and initially initial derivation of the three hinges Stefaning Gadder. Same thing you draw here. And how to draw the influence line I will explain clearly. If you know this diagrams and this value, easily you calculate the all these things within fraction of seconds. If you finish the draw the figure, please intimate me. I will continue. Clear? Enough time is there? Sufficient? Students? Okay. Haripriya? Are you follow?
Sir, yes, sir. 1 minute, sir.
Okay, okay, right. Please understand this concept clearly. Very easy. Influence lines. Already learned in second semester. One by one, I will explain. Don't draw all figures are at once. I will explain influence lines for W. Then you meant stick for that figure. In class in that. And again, I will explain the how to draw the influence line for horizontal reaction. Then you go for figure C. Don't draw all figures at once. are confused. Okay.
Yes, sir.
Hemant Verma, are you finished? Yeah. So for this given problem, our problem is this one. Figure A will gives our problem. Three hinges. The Stephen gutter is having three hinges at D point and E point, and third hinge at F point. And that the placing is known. L3. The third hinge will be placed. Okay. The placing will be known. No, the third hinge will be placed at a distance L3 from left support, and total length of the gutter is L, and A is the position of the point G on the gutter. At any point G on the gutter is placed A from support A. Now I want to draw the influence lines diagram. For what you know, what is the W value in the derivation? What is the W equation? So the influence, put a heading influence line for W. The influence lines for W, small w, may be obtained from that equation. What is the equation W in the derivation? Haripriya? Already you derived an equation 1 and now. What is the equation W? Hello? What is the value equation? Already you derived, na? W is equal to 2mb by L3 into L4 వచ్చింది కదా ఈక్వేషన్. ఏం మాట్లాడరేంటండి?
వాయిస్ వినపట్లేదండి సార్.
వాయిస్ వినపట్లేదా?
వాయిస్ వినపట్లేదు.
ఈక్వేషన్ 4 పాయింట్ నేను ముందే చెప్పాను, ఇవన్నీ ఈక్వేషన్స్ అంటే చాలా ఇంపార్టెంట్ టు డ్రా ద ఇన్ఫ్లుయెన్స్ లైన్స్ అని చెప్పాను. సో యు డ్రా ద ఇన్ఫ్లుయెన్స్ లైన్ ఫ్రమ్ దిస్ ఈక్వేషన్. W is equal to 2mbf by L3 L4. But what is mbf? It is the bending moment at a particular point, F point, due to applied load in a simple beam. So దీని పక్కకు పెట్టండి. అప్పుడు ఏమవుతుంది? 2 into W, 2 into L3 into L4. What is MB? If any simply support beam subjected to uniform distributed load, what is MB? AB by L. That is the influence lines coefficient. Already you learned in the previous chapters, previous semester. So substitute here 2 into L3 into L4 into what is MB? AB by L. What is AB? L3 into L4 by L కదా AB అంటేని. Here, what is AB? I want, this is the simple uniform distributed WAB by L. AB by L, ordinate will be AB by L. So what is A? L3 into L4. So AB is the A is the L3 and B is L4. So L3 into L4 by L into equation. You put unit force MB in this equation. So 2 into L3 into L4. Therefore, you get the 2 by L. Can they get cancelled? 2 by L. So this is the ordinate. This is the ordinate 2 by L. Clear? So let us see here this slide. First understand, think yourself. చూపించేస్తా మీకు క్లియర్ తెలుస్తుంది ఒకసారి ఏమంటున్నారో తెలియాలి కదా. So this is the equation obtained. So 2 by L 3 by L is nothing but 2 by L. This is the ordinate given in the equation B, 2 by L. From this figure, influence lines figure, you calculate the W. Clear?
Yes, sir.
Similarly, you draw the figure B, figure C, influence lines for H. That is also L in terms of Y dash C, L1 L2 by L into by C, and L by 4 Y dash M. If it is mid-span matter, how it is? Again, you calculate the influence coefficient. You know, already you know that what is the equation for horizontal reaction? WL square by 8 Y dash M. You know, already derived in the previous process. So what is W? 2 by L. You substitute here 2 by L. Then you get the L by 4 dash M. That is the alternate given the L by 4 by dash M in terms of mid-span. Or in terms of alternative method, in terms of L1, L2, you know the 8 by L. And this one L1 by L2 in terms of YC. Y dash in terms of Y dash C, L1 by L1, L2 by L into YC, Y dash C. In terms of Y dash M, L by 4 YZ. So that's why I'm giving here the ordinate is L1, L2 by L1 Y dash C. Both I will give in terms of Y dash C and in terms of Y dash M. All these are derived from the previous formula. Em formula? This one. This is the formula. Clear? Already derived all these things in terms of Y dash C, in terms of Y dash M. This is the Y dash M. Okay, and equation 4.3b. (4.3a)(3b) will give the
Horizontal tension.
Yeah, from these two equations, you draw the influence lines diagram like this. It is also in this one. It's a triangle. The ordinate will be like this. If you know the L1, L2, Y dash C, use this equation. If you know the Y dash M, use this equation and find the ordinate. And once you know the ordinates, remaining using similar triangle concepts, find the other ordinates and multiply the ordinate, multiply the load will give the total. Okay. So this is the influence lines for H. And coming to the bending moment, again you go for this equation. What are the equation? Bending moment equations. MB minus WX 2 into L minus X. So from these equations, you draw the figure. Influence. See, the influence line for mg at particular g may be shown in this figure. This is the mg influence lines for mg. Now, combining the influence line for mbg and W. Here there are two components, MBZ. What is MBZ? Bending moment correspond to simply supported beam at a particular point G. That one, and also influence lines for small w. So the combining the will give the influence line for mg. So let us see in place of equation, simply put x is equal to a. That's enough. mb minus w a by 2 into l minus a. That's enough. So both ordinates are equal to ab by l, ab by l. Both ordinates are equal to ab by l and ab by l. And once you know the ordinates and place the rolling loads or moving loads at particular points and find the ordinates. See here, cursor movement. Find the difference of ordinates of this triangle and this triangle and multiply with load and add all loads will give the total bending moment. That's enough. So this is the, see, simply I will put a A. Why I am given combining of MBC and W like this? Because in place of X you put A, then it will become MBC. That means simply bending moment at G in simply support beam, and it is bending moment diagram of W. You know W. So both influence are AB, whose triangles are same, AB by L and AB by L. So using this triangle, these triangles, you can draw the, you can find the bending moment at any section. Once you know the ordinate, here you are recognized for W is the ordinate is 2 by L. For H ordinate is this one, and for bending moment ordinates are AB by L in both cases at any particular point. Both are same. And coming to the shear, same. You can go for shear equation 4.9 and 4.10. In place of you put x is equal to a, that's enough, and w is equal to by l. Then you got this equation. This is the ordinate at a particular point f. 1 minus 2a by 1 minus 2a by l. And already you know this is a by l and this is b by l. At particular point G, this is A by L and this is B by L. మీకు వచ్చిన రాకపోయినా ఇది బట్టి కొట్టుకోవడమే. మీరు కావాలంటే మీరు వెళ్ళి ఇన్ఫ్లుయెన్స్ లైన్ చాప్టర్ తిరగేయండి. I cannot explain all these things in this situation. So this is the A by L, this ordinate is A by L and this ordinate is B by L. And at particular point F, ordinate is 1 minus 2A by L. Right? So using these influence lines diagrams, you can calculate the bending moment and shear. Already you know the how to calculate the H analysis of cable. Already you can do the 2 or 3 problems. In addition to that, same problem you add stiffening girders and to analyze the stiffening girder for a particular load by using influence lines. Draw the bending moment diagram and draw the shear force diagram. Clear? ఇక్కడ మొత్తం అన్ని కూడా F is not center. Third hinge did not located at mid span. For this case, this is the influence diagram for intensity of flow as shown in figure B. Intensity of horizontal reaction, influence lines for horizontal reaction for that case shown in figure C, and influence lines for bending moment at F and G, at M, at G, at a particular point G, shown in figure D, and influence lines for shear force at point G, this one. But what is you understand? The F is eccentric, situated at a distance of third hinge will be kept at a distance L3. If third hinge will be kept at L by 2, that means mid span, then the figures are like this. So what is the difference between previous problem and this problem? The third hinge will be kept at the mid span L by 2. For this L by 2, same influence lines for W is 2 by L as it is, and influence lines for H is become L by 4 YC. 4 YC.
Sir.
Yeah.
Sir.
Yeah. Here influence lines for MG is same as it is AB by L, AB by L. And influence for Q shear A by L and B by L. And the ordinates are 1 minus 2A by L. So this is the difference between the previous figures and this one. Only difference is location of the third hinge. In the first one, the location of the third hinge is not at midspan. In this figure 4.3 will gives the location of the third hinge will be kept at the midspan. When it is midspan, that means location of the third hinge on the midspan. Use these diagrams and find the things. All of you draw all these things. ఇవి మీకేమైనా అర్థం కాకపోతే వెంటనే ఇమీడియట్గా అడగండి. ఇప్పుడే ప్రాబ్లం అంతా వీటి మీద బేసే ఉంటాయి. Very simple problems. Within 5 minutes to తెలిపోయే problems ఇవన్నీ కూడా. If you have understand properly how to draw these figures, that's enough. Are you hearing my voice, students?
Yes, sir. Yes, sir.
Yeah. If you have any doubt, please ask me. And also you draw the individually these figures separately. Special. Take the problem. ఒకే ఒక ప్రాబ్లం చెప్తాను. మనం y డాష్ m కట్టాం కదా, రెండో ప్రాబ్లం గుర్తుంది, అనాలిసిస్ ఆఫ్ కేబుల్. స్టూడెంట్స్, అనాలిసిస్ ఆఫ్ కేబుల్లో సెకండ్ ప్రాబ్లం కట్టాం కదా. స్టూడెంట్స్, మనం సెకండ్ అనాలిసిస్ ఆఫ్ కేబుల్ ప్రాబ్లమ్ లో సెకండ్ ప్రాబ్లం వై డాష్ ఎం కట్టాం రైట్ హ్యాండ్ ట్రయాంగిల్ ద్వారా. ఆ ప్రాబ్లం మనం స్టెఫెన్ యాడ్ చేద్దాం. I will show that problem. This problem. A cable is suspended between 2 points A and B located 50 meters apart. The point B is higher than the point A by 12.5 at 12.5 meters. At midspan, the cable is located 9.375 below A. The load on the cable is distributed uniformly per unit length of the span. Don't know what is uniform distributed load. Determine the position and sag of the lowest point. Determine the position and sag of the lowest point and also curved length of the cable. దీనికి ఈ ప్రాబ్లం కి మనం గట్టర్ అటాచ్ చేద్దాం. ఓకేనా? ఆల్ ఆఫ్ యూ ఫెమిలియర్ విత్ దిస్ ప్రాబ్లం. దీనికి ఏం చేసాం? లెట్ us y dash m కాలిక్యులేట్ చేసాం. See here y dash m how to calculate 15.625. From this you know the y dash m and it is subjected to uniform distributed load. Find the horizontal reaction WL square by 8 y dash m and using a very important equation WL square by 2yc and find the yc lowest point of the cable yc how much in terms of L1 square and equating to both equations, then you get the eliminate the W and find the L1 is 20 meters, L2 is 30 meters and YC is 10 meters. This is the solution taken from the analysis of cable. Using these equations, these parameters, you can derive the analyze the Stefan and Gatter. Are you understand? Students? Okay, hello.
Yes. అర్థమైంది సార్.
ఇప్పుడు మనం ఆ ప్రాబ్లమ్ కి స్టెఫెన్ గట్టర్ యాడ్ చేసాం. యాడ్ చేస్తే యూ కెన్ కాలిక్యులేట్ ఆల్ దీస్ థింగ్స్. L1 is 20 meters. Let us use these values. What is the L1 is 20 meters. L2 is, and what is the L1? It is the position of lowest point C. Yeah. And remaining is 30. And what is YC? Dip or vertical alternate at the lowest point from the support A is 10 meters. Then curved length is a formula. Use curved length and find. So for this problem, I attached a Stefan and Gatter. Let us see how it is. Yeah. A suspension cable in previous example is stiffened by 3 hinges stiffening Gatter having internal hinge is in the same vertical line as lowest point. So here internal hinge lowest point kuda oke vertical line మీద ఉంది. అంటే ఏంటి? The position of the lowest point of the cable and position of the third hinge kuda same. Okay na? As a vertical point, lowest point of the cable as indicated as shown figure. Determine the horizontal reaction in the cable and also draw the bending moment and shear force of the Gatter. This is the that cable problem is attached to the Stefan and Gatter. Clear, students?
చేసుకుంటున్నాం సార్ ఒక్క నిమిషం.
Let us note down this problem. ఆ ప్రాబ్లం కి ఇది కలుపుకోండి.
తీసే గురు బొక్కల్లో ఉంటుంది ఇప్పుడు అసలు ఇంకా
ఏమ్మా ఏటమ్మా పాడా Okay. So this is the figure A. DE is the Stefanen gutter. For this third hinge, F is placed at the lowest point 20 meters. And it is subjected to one vehicle, one wheel load will be kept at the center. 25. This is the given figure A. Figure A is given. You can draw the figure B and figure C from the equations. So that problem. The suspension cable in the example 2-3. In the previous analysis of cable lo mana problem ichu ade problem and extend chestunnam. Same problem extend chestunnam. ఎందుకంటే అదే కేబుల్ కాదు కదా కేబుల్కి గట్టర్స్ అటాచ్ చేస్తారు ఆ తర్వాత గట్టర్ కేబుల్ గట్టర్ కలిపి పీర్కి అటాచ్ చేస్తారు సో పీర్లో వస్తుంది అది సో for this problem the stiffened by 3 hinge stiffening gutter having internal hinge in the same vertical line as the lowest point. Where you get the lowest point in the previous problem 20 meters from left support. So third hinge will be kept at it. Indicate as shown for figure lo vadi chesadi cheppadu. So determine the horizontal tension in the cable. Also draw the bending moment and shear force diagram of the gutter. So from the figure A is given. It is subjected to cable and gutter is connected with hangers. First చూపించాను మీకు గుర్తుందా ఫిగర్ సస్పెన్షన్ ఫిగర్ గుర్తుపెట్టావా this one. So this is suspension cable and DE is the gutter and these two gutter and cable is connected by hangers. These are the hangers. So the any vehicle is passing over the gutter, that dead load of the gutter will be distributed upward. See here upward arrows. That is load transfer to the cable through uniform distributed load. And this one that so shown in figure C here see upward direction load indication is upward direction is uniform distributed load that will be seen in the our problem. మీకు ఇవన్నీ కూడా మీకు మైండ్ లో ఉండాలి yeah this one what is this W upward dead load of the gutter like this. So this is the figure A is given. For this you can calculate the horizontal reaction and draw the bending moment diagram for the gutter and draw the shear force diagram by using influence lines, right? So here in the previous problem L1 is equal to L3 is equal to 20 meters and L2 is equal to L4 is equal to 30 meters. All of you know that one. And let us find the horizontal tension in the cable. So you know the bending moment corresponding to simply supported beam for this figure. How much bending moment at F at center? ఇక్కడ ఎంత అండి సెంటర్లో ఎంత ఉంది 120 కిలో న్యూటన్ కదా సింపుల్ బీమ్ సబ్జెక్టెడ్ టు 120 కిలో న్యూటన్ వాట్ ఇస్ ద రియాక్షన్స్ కాలిక్యులేటర్ తీయండి మనకు హారిజాంటల్ దిస్ will be ordinate. If you know this ordinate and multiply with 120, then you will that bending moment divided by y dash m y dash. అదే కదా h అంటే ఏంటి mb f by y dash because y dash ఎందుకంటున్నాను supports are at different levels. If supports are same level, yc or y. So here the bending moment at F, first find the bending moment at F corresponds simply support beam. Are you getting the 1200 kilonewton meters for external load W 120 kN? Hello? Draw the simply supported beam and identify the 120 kN where it is and find the reactions, and I want to find the bending moment at F. What is the problem? Find the reactions and take the moment at F. Are you getting 1200? Students? ఎవరు మాట్లాడరేటండి బాబు 85 మెంబర్స్ ఉన్నారు హలో హేమంత్ వర్మ
Yes, sir.
మాట్లాడరేమి అంతసేపు నేను మరుస్తుంటేని 120 వచ్చిందా 1200 కిలోమీటర్ మీటర్ వచ్చిందా మీరు చేయవలసింది సింపుల్ లెక్కది లెట్ us టేక్ సపరేట్లీ సింపుల్ డ్రా చేయండి సింపుల్ సపోర్ట్ బీమ్ and put at 120 kilonewton at center. Already ఇచ్చాడు కదా ఇక్కడ మన ప్రాబ్లంలో ఇక్కడ ఇచ్చాడు కదా ఇదే సింపుల్ సపోర్ట్ బీమ్ డ్రా చేయండి అక్కడ ఏమో 120 ఏమో 25 మీటర్స్ పెట్టండి ఆ సింపుల్ సపోర్ట్ బీమ్ సబ్జెక్ట్ టు సెంటర్ కాన్స్టెంట్ లోడ్ కి ఐ వాంట్ టు ఫైండ్ ద బెండింగ్ మూమెంట్ అట్ F. ఎంత వచ్చింది బెండింగ్ మూమెంట్ అట్ F? కాపీ చేసుకోండి. This is the 1200 60 into 20 and yc dash is calculated 15 meters by using the same concept. నేనేం చెప్పలేను ప్రీవియస్ ప్రాబ్లమ్స్ చేయకుండా కూర్చుంటే నేనేం చేయగలను I cannot do anything. So mb by y dash c is h is equal to 1200 by 15 is 80 kilonewton. A very simple principles. So like that you get the horizontal reaction is 80 and find the W. You don't know how much once you know the horizontal reaction then you determine the W also. So how you calculate the W? Taking bending moment for this problem. Taking bending moment at E equal to, because E is the take the free body diagram for simple beam, act as a simply supported beam. Therefore, it is a hinge support. This is the roller support. That means D is having hinge support, and E is a roller support. And find the taking moment about E point. All these things. Take moment about E point for this. Then what is the equation? Sigma m equal to 0. Vd into 50 plus W into 15 50 by 2. Both are clockwise direction because it is upward. This is upward force creating clockwise, and 120 is creating downward, which is creating anti-clockwise. 120 into 25. That must be equal to 0. This is the equation A. Again, you take the bending moment at F equal to 0. Let us take here. This is the determinate Stefan Gutter. It is very simple to know the uniform distributed load by taking moment at E and at F. Solve these two equations and get the W is equal to 4. After knowing this 4, you can draw the bending moment diagrams. Simple problem. ఏముంది ఇందులోని హారిజాంటల్ రియాక్షన్ ఫైండ్ అవుట్ చేయాలంటే ఆ పర్టికులర్ పాయింట్ దగ్గర బెండింగ్ మూమెంట్ డివైడెడ్ బై ఆ పర్టికులర్ పాయింట్ దగ్గర వర్టికల్ ఆర్డినేట్. దాట్స్ ఎనఫ్. ఆ పర్టికులర్ పాయింట్ దగ్గర అంటే ఏంటి? సి దగ్గర. థర్డ్ హింజ్ లోయెస్ట్ పాయింట్ కూడా సి దగ్గరే ఉంది అని చెప్తున్నాడు ఆ ప్రాబ్లంలో. సో వాట్ ఈస్ ద వై ఇది సపోర్ట్స్ ఆర్ అట్ డిఫరెంట్ లెవెల్ కాబట్టి వై డాష్ ది కనుక్కుంటారు. వై డాష్ ఎట్లా కాల్కులేట్ చేస్తారో అలాగే వై డాష్ సి కూడా కాల్కులేట్ చేస్తారు. ఆల్రెడీ వైసీ మనకి 10 తెలుసు. ఎనాలిసిస్ ఆఫ్ కేబుల్ నుండి మనం ఎనాలిసిస్ చేస్తాం. అన్ని ఒకటే ప్రాబ్లం అంతా కూడా. ప్రాబ్లం అదే ఎత్తాడు ఎండ్ ఎగ్జామ్లో ఇవన్నీ చేయాలి. సో 10 అని తెలుసు వైసీ. అండ్ ఫైండ్ ద వర్టికల్ ఆర్డినేట్ అట్ ఇన్క్లైన్డ్ లైన్. దట్ విల్ బి 12.5 by 15 to 20. That is 15 meters. హలో, ఎక్కడున్నారండి? ఎప్పుడు వస్తారండి? ఇప్పుడు నేను క్లాస్లో ఉన్నాను. 12:30కి వస్తారా? అంటే మీరు వచ్చేసరికి ఎక్కడున్నారు మీరండి? అన్సిగా వచ్చేసరికి ఆఫ్టర్నూన్ అవుతుంది. చిన్నమేరం అండి మాది. రండి, లేకపోతే ఒకసారి రండి సార్. అప్పుడు అయిపోతుంది, మ్యాక్సిమం క్లాస్ అయిపోతుంది. రండి, అయిపోతుందండి. మీరు వచ్చారు. అది స్ట్రైప్స్ కింద వస్తున్నాయండి. పిక్చర్ రావట్లేదు, వాయిస్ వస్తుంది, పిక్చర్ రావట్లేదు. కాపీ చేస్తున్నారా? Now let us, after knowing the H is 80 kilonewton, first one, and you know the how much uniform distributed load it transfers to the cable, 4 kilonewton per meter. From these two you can draw the bending moment diagram. Let us see how to draw. Let us take the what is 1250 WL square by simple beam. WL square by 8 అయ్యండి, అంతే కదా. సింపుల్ బీమ్ సబ్జెక్టెడ్ టు అప్వర్డ్ యూనిఫామ్ డిస్ట్రిబ్యూట్ లోడ్. అంటే యూనిఫామ్ డిస్ట్రిబ్యూట్ లోడ్ అంటే ఏంటి? WL square by 8 కదా. సో you can use WL square by 8 where W is equal to 4. Then you get the ordinate. See here, parabolic, because it is a uniform distribute load. You draw the parabolic shape of the bending moment diagram like this. You follow my cursor. Are you understand? All of you see observe my cursor position. Follow my cursor position. So once you know the W is equal to 4 kilonewton per meter, entire beam is subjected to this load. Therefore, simple beam subjected to uniform display. What is the formula? WL square by 8. So the like this use this is the 1250. This is the 1250. Use draw the Bandamund diagram because it is a uniform distributed load like this. And then you draw the Bandamund diagram simply being subject to the central concentrated load AB by W by WL by 4. So this is a triangle because it is a concentrated. The Bandamund diagram is triangle. So what is the ordinate at center? WL by 4 and then W is equal to 120. WL by 4 and how much? Students? హలో కాలిక్యులేటర్ ఉన్నాయా?
Sir.
ఎంత ఆర్డినేట్? పదిహేను వందలండి. 120 ఇంటూ ఎల్ అంటే 50 WL by 4. So 1500. So difference is it is total ordinate is 1500 for concentrated load and ordinate for uniform distributed 1250. So what is the difference? Is a 1250 that one 1250. This ordinate is 1250. So point of contraflexure is at F. Bandamund is 0. Therefore, either side it is 20 meters. It 20 meters. So this is the way of drawing the Bandamund diagram, right? And draw the shear force diagram. And simply being subjected to central concentrated. What is the reactions? 60, 60. Therefore, this 120 kilonewton is acting downward. Therefore, the reactions due to 120 kilonewton is acting upward at the hinge supports. So let us draw the left upward is positive. Therefore, you draw up 60 and it is uniform up to center. And right up is negative. Therefore, you draw 60. So these two blacks are 60 and this 60. Shear force due to 120 kilonewton and shear force due to 4 kilonewton per meter. How much? 4 kilonewton per meter is acting upward. Therefore, the reaction at support D and E is acting downward. So left downward is negative. Therefore, WL by 2, WL by 2 is nothing but 100. So you draw the Bandamund diagram 100. That means up to this point, this is 60 and the remaining point is 40. So total ordinate is 100. So this is also up. You connect these two lines. So this is the way of drawing the shear force diagram. Very simple case. Are you understand? Clear? So shear force diagram. The next shear force diagram as shown figure C may be obtained by shear force diagram on account of downward concentrated load and uniform distributed load. Then explain చేసింది అక్కడ రాస్తాను అంతే. That's enough. So this is the problem for figure second problem. Extend to the attached to the gutter with the load of something 120 kN load. Have you any doubts? Doubts ఉంటే అడగండి, లేదంటే నెక్స్ట్ ప్రాబ్లంకి వెళ్ళిపోదాం. ఎనభై 2 మంది అటెండ్ అయ్యారు, ఒకరు మాట్లాడలేదండి. నాకే వచ్చి ఎక్కువ వస్తుంది, ఎందుకు పాడైపోతుంది కదా, ఎందుకు అలా ఫ్రిడ్జ్లో పెట్టడం కూర్చున్నట్టు తినేక బాగా ఎక్కువ అయిపోయింది. యాపిల్స్ కూడా తినట్లేదు పిల్లలు. నాది యూట్యూబర్ పట్టా స్టూడెంట్స్ ఏం మాట్లాడలేదండి. Are you understand to draw the bending moment diagram and shear force diagram for single wheel 120 kN wheel? This is a static approach. One weekend మనం కంప్లీట్ ఇచ్చి static load condition. Okay, static load అయితే you can follow like this. First you do the analysis of cable and find the YC and L1 lowest weight. After that you find the third hinge will kept at the same position. For that load you can calculate the load uniformly, how much load will be. 120 kN load is passing over that bridge, which is placed at the center for static load. As a static load procedure will be followed. Okay, let us see. Write down a symmetrical suspension bridge is formed by a set of two cables placed side by side at a distance of 6 meters from the 6 meters over the span of 90 meters, and the central sag is 18 meters. Each cable is stiffened by means of 3 hinged stiffening gutter having an internal hinge at midspan. Now it is internal hinge is kept at the midspan. In the previous problem it is not there. The total dead load assumed to be uniformly distributed load is 4.8 kN per meter square. So dead load is also given, small w also given on the floor. floor area. Determine the maximum tension in the cable when the bridge is transferred by an axial load of 450 kN is placed symmetrically with respect to the longitudinal axis of the bridge. This is the problem. You can copy the problem. Within 10 to 15 minutes, this problem is over. Please write problem and understand properly.
Sir.
ఏంటి ఏం స్క్రీన్ ఏం షేర్ అయింది స్క్రీన్?
Parts of suspension first లో చూపించింది సార్.
ఇప్పుడు ఎందుకు ఇది తీసుకొచ్చి పెట్టానంటే ప్రాబ్లం చదువుతూ ఇది చూడండి సరిపోతుంది. ఏంటది? ఏ సిమెట్రికల్ సస్పెన్షన్ బ్రిడ్జ్ ఈస్ ఫార్మ్డ్ బై సెట్ ఆఫ్ 2 కేబుల్స్. అంటే నేను ఇక్కడ వన్ సైడ్ చూపిస్తున్నాను, అట్లాగే అటేపు కూడా ఇంకోటి ఉంది, మధ్యలో రోడ్ ఉంది. అది మీరు అర్థం చేసుకోవాల్సింది. A symmetrical suspension bridge, and symmetrical and supports are at same level. A symmetrical suspension bridge is formed by set of 2 cables placed side by side at a distance of 6 meters. And road width anta aa cable ki ee cable ki ni 6 meters. Enta span 60 meters, 90 meters. And the central sag YC, lowest point of the cable is central sag, and supports are same level. YC is given 18 meters. Everything is given in the problem. So each cable is stiffened by means of 3 hinge stiffening adder at supports at center. 3 hinge stiffening adder having an internal hinge at mid span. So mid span kuda ante enti third hinge, internal hinge, and lowest point of the cable it falls in same vertical plane at mid span. And the total dead load is assumed to be uniform distributed 4.8 meters square. Floor area ichadu, width of the road ichadu 6 meters. So uniform distributed ఏ ఫార్ములా ఉంటుంది? W per meter length లో ఉంటుంది, not W per meter square. So this 4.8 multiply with 6, you get the uniform distributed load, W kilonewton per meter. That's why they are given data. And determine the maximum tension in the cable when bridge is traversed by an axial. One single load is going on, which is 150 kilonewton symmetrically with respect to the longitudinal axis. Now understand? I think you have an idea from this figure. You can visualize, imagine other side also. Supports are same level, symmetrical anade kabatti. Can you start the solution?
Yes, sir.
So first find the dead load of the gutter. Because 4.8 kilonewton per meter square is given, you should convert it to kilonewton per meter. So 4.8 into 6, that is the dead load. But that load will be carried by two cables. So I want to find each cable divided by 2. So 14.4 kilonewton per meter is the dead load. And live load for gutter, live load also we calculate the per gutter. So what is the live load? 450 roller. That also divided by 2. So the live load per getter is given 225 kilonewton. So now this is in a uniform distributed load. This is in concentrated load. This will be converted into the uniform distributed load by multiplying the influence line diagram. Already you know influence line diagram for the W, small w, this one. Already you know what is the influence line diagram for the small w? 2 by L. So that load multiplied the 2 by L will give the uniform distributed load. That's why I'm so live load per getter is equal to 225 into 2 by L. L is 90. So live load at the 5 kilonewton per meter. So total load on the cable is dead load 14.44 plus live load 5 is 19.4. Clear? Then once you know the dead load, you find the vertical reaction WL by 2, WL by 2, 840, and you know the YC is given, W is known, YC is given 18 meters, then MB by YC. What is MB? WL square by 8, WL square by 8 divided by central dip 18. You know the V, you know the H, and find the. He is asking what he asking? What he asking? Determine the maximum tension of the cable. So maximum tension of the cable is equal to S maximum is equal to H square plus V square. It is uniform. The cable is subjected to uniform distributed load. Therefore, H square is equal to 1091.25 whole square plus 873 whole square by. So this is the one type of problem. Clear? Students, very simple question. You need not put a broad mind on this problem. Emma, just use this influence line B figure, then you are already everything is no. Hello, students. వీళ్ళు అర్థమవుతుంది లేదు తెలియట్లేదు ప్రాబ్లమ్స్ కదా నా బాధ నాది వాళ్ళు ఏం మాట్లాడట్లేదు ఎవరో ఒకరు మాట్లాడుతూ అంటే నాకు ఓకే వినపడుతుందన్న ఫీలింగ్ లో ఉంటాను
వినిపిస్తాను సార్
అర్థమవుతుందా ప్రాబ్లము నేను చెప్పిన చిన్న ప్రాబ్లమ్స్ అది డ్రా చేసుకుంటే ఇన్ఫ్లుయెన్స్ లైన్స్ తెలుస్తుంది ఇక్కడ ఏదో ఓన్లీ ఇన్ఫ్లుయెన్స్ లైన్స్ యూజ్ చేసి కాన్సన్ట్రేటెడ్ ని కన్వర్టెడ్ చేస్తే యూనిఫామ్ డిస్ట్రిబ్యూట్ అన్న కాన్సెప్ట్ తెలిస్తే అయిపోయింది అంతే ప్రాబ్లం ఇక్కడ ఏం లేదు ఎందుకంటే రెండు కేబుల్ షేర్ చేసుకున్న దాన్ని లోడ్స్ పర్ కేబుల్ కట్టాం ఏంటి డివైడ్ బై 2 చేస్తాం ఓ టైం యూనిఫామ్ డిస్ట్రిబ్యూట్ ఉంది రెండోది ఏమో కాన్సన్ట్రేట్ లోడ్ ద కాన్సన్ట్రేట్ is converted to uniform distribute by multiplying the influence lines coefficient by 2 by L. That's enough. You know the W. So W తెలుసు symmetrical supports and supports the same level. YC everything is given. YC is given. W తెలుసు maximum bend moment తెలుసు మీకు WR square by 8. Find the H and V. That's enough. Now coming to the second problem. A cable of suspension bridge stiffened by 3 hinges stiffening gutter as shown in figure. The span has 120 meters and the central sag is 20 meters. Thank you. 20 meters. Determine the maximum value of horizontal tension H in the cable and positive negative values of bending moment and shear force at right quarter point G of the span due to rolling load shown in figure. This will be the completely depends upon influence line. This one figure is like this. This is the figure B. Figure A is given. Write down. First of all, write down the problem. Thank you, Ram. త్రీ హింజ్ స్టెఫెన్ గట్టర్ మీద చూసా ఎన్ని ప్రాబ్లమ్స్ ఉన్నాయో చక్కగానే so many models, but you don't miss concept. Concept is important. Oi. Maru. Mechanic వచ్చాతా అన్నాడు. It will take 25,000 rupees at another double. DE అదన్నీ కూడా హారిజాంటల్ రియాక్షన్, బెండింగ్ మూమెంట్, షీర్ ఫోర్స్ ఇవన్నీ తర్వాత చూద్దాం. Figure B is also given in problem. So D is the girder, D and E, and which is 90 meters, and third hinge is at third hinge will be kept at center. That means 60. It's 60, and four wheel load. And one car entadi, car or bus edo. Four wheel load is passing over that one. First load is 20 from right to left. First load, second load, third load, fourth load. So first load is 20, and second load is 40, and third load is 20 kN, and fourth load is 20 kN. This wheel load will be passing over this girder. So while this passing over the girder, what is the maximum horizontal reaction developed in the tension? What he asked? Maximum value of the horizontal reaction in the cable, and అడగవలసింది అదే. ఇంకేముంది? అనాలిసిస్ ఆఫ్ కేబుల్, అనాలిసిస్ ఆఫ్ సస్పెన్షన్ బ్రిడ్జ్ అంటే ఏంటి? వాట్ ఈస్ ద మాక్సిమం టెన్షన్ క్యారీడ్ బై ద కేబుల్? one parameter. Another parameter, what is the shear force and bending moment of the stiffening girder? That's enough. అదే అడిగాడు వీడు. ఎక్కడ అడిగాడు? షీర్ ఫోర్స్, బెండింగ్ మూమెంట్ రైట్ క్వార్టర్ స్పాన్ దగ్గర అడిగాడు. అంటే రైట్ సైడ్ L/4 దగ్గర అడిగాడు. దట్ మీన్స్ ఫ్రమ్ 30 meters ఫ్రమ్ సపోర్ట్. దిస్ ఇస్ ద question. Okay na? Rajas got a figure. Don't draw the C, D, E. Only this is the problem. Figure B is the problem. Figure B. Right. Sir, వచ్చారా? సూర్య ఎన్క్లేవ్ 5th floor కి వచ్చండి. 5th లిఫ్ట్ ఎక్కి 5th floor. 501, 401. 5 అంటే 5 లిఫ్ట్ పక్కనే ఉంటుంది.
sir.
Using influence line diagrams, you can draw the influence lines ordinates and place it and find the other ordinates. I will explain in the next class. Okay, let us stop here. Tom, next class we will finish this chapter. Thank you.